Weighted averages. The test sometimes will ask us the combined average of two or more different groups. So here's a sample problem. We're not going to do this sample problem right now, but just to give you an idea of this kind of question. On a ferry, there are 50 cars and 10 trucks. The cars have an average mass of 1,200 kilograms, and the trucks have an average mass of 3,000 kilograms. What is the average mass of all 60 vehicles on the ferry? So in other words, we have two different groups that are unequal size. They have unequal averages, and we'd like to figure out the average of everyone combined together. So that's the basic gist of this problem type. There are a few different ways to approach problems such as this. The first approach would be to think in terms of sums. As we discussed in the first lesson of this module, thinking in terms of sums can often simplify problems about averages. In that problem with vehicles, since all the masses are in thousands, we do the calculation with everything divided by 1,000 for much simpler numbers. So it just makes our life easier to make everything 1,000 times smaller. So here's the problem again. So we'll just work through this problem together. The car sum is 50, and instead of using 1,200, I'm just going to divide it by 1,000. I'm going to call that 1.2. 50 times 1.2, well, that turns out to be 60. And then the truck sum is going to be 10 trucks times 3,000 divided by 1,000, so that's 10 times 3, which is 30. That means the total sum is 90. Well then, 90 divided by 60 vehicles, that's 9 divided by 6, that's 3 halves, or 1.5. And now we just multiply that by 1,000, 1,500 kilograms. That has to be the mass of all the vehicles together, all 60 vehicles on the ferry. Using sums is one way to approach weighted average problems. It's one good trick to have up your sleeve. Another approach involves thinking about proportions, and this is very important to understand also. Each group of individuals is some proportion of the entire pool. We can simply multiply the average of each group by this proportion, find the sum of all those products, and that sum is the average of the entire set. So for example, symbolically, suppose there are 3 groups, 3 different size groups, and they have averages A1, A2, and A3. Those are the averages of these 3 different groups. They have 3 different averages. Furthermore, the first group is P1 of the whole. That's its proportion, the proportion of the whole. The second is P2, the third is P3. These 3 proportions should add up to 1, because together they all add up to the entire group. So what I'm saying is we can multiply every average times its corresponding proportion and then add these products together. So the average of the whole equals A1 times P1 plus A2 times P2 times A3 plus P3. This is a very important idea. So pause the video and then work on this problem. Alright, so here we don't even have the absolute number of employees. All we have are the percentages. So if you're given percentages, it's a very good indication that you're to solve the problem using proportional thinking. So what we're going to do is we're going to take each one of those percentages, change it into a decimal, and multiply it by its corresponding salary. And again, we're going to make these salaries much, much smaller. We're going to divide them all by 1,000. So the total is going to be, for the marketers, that's 0.7, 70% is 0.7, and then their salary we're going to count as 40 instead of 40,000. The programmers are 20%, which is 0.2. Their salary is going to count as 80. And the managers, 10%, that's 0.1 times their salary, 120. So we're just going to do all the multiplication there. We get 28 plus 16 plus 12, that adds up to 56. Remember, we divided by 1,000, so this 56, it really should be 56,000. That's the average salary of all those employees at the company. We can use another kind of proportional reasoning if the weighted average involves only 2 groups. So this is really complicated, but if you understand this, this is incredibly powerful and incredibly useful. Suppose the two groups have proportions P1 and P2, where P1 plus P2 equals 1, and where P1, we're just going to pretend P1 is the bigger group. So P1 is larger than P2. The average of the whole collection will be between the averages of the individual groups, and in fact, it will be closer to the average of the bigger group. That makes sense. The bigger group is going to have more of an influence, so the average is going to be closer to the bigger group. Think about this all on a number line. We're going to have A1 somewhere on the number line. We're going to have A2 somewhere on the number line. Somewhere between them, we're going to have A total, the total average of the group. Of course, it's going to be closer to A1 and A2. And suppose we look at those distances. So D1 is the distance on the number line from A1 to the total average. D2 is the distance from A2 to the total average. All right? Here's the interesting part. The ratio of those distances is inversely proportional to the ratio of the two proportions. In other words, P1 over P2, the ratio of the two proportions, equals D2 over D1. And this makes sense because the one that has a larger size, a larger proportion, is going to be closer to the average, so it's going to have a smaller distance, a smaller separation from the average. All right, well, this is interesting. How on earth are we going to use this? So let's first of all talk this through very carefully using this problem. We actually solved this problem earlier, but we're going to solve this same problem another way right now. So we have 50 cars, 10 trucks. So the cars are the bigger group. The cars have an average of 1,200. The trucks have an average of 3,000. We know that the total average has to be closer to 1,200 than to 3,000, and we want the total average. Well, the ratio of cars to trucks clearly is 5 to 1, or 5. So another way to say this is that cars account for 5 parts, the trucks account for 1 part, and so the total is 6 parts. And so the proportions, in other words, cars are 5/6 of the vehicles on this ferry, and trucks are 1/6 of the vehicles on this ferry. So those are the proportions. And that ratio, 5/6 to 1/6, that's just a 5 to 1 ratio. Now we're going to look at the distance between the two averages. 3,000 minus 1,200 is 1,800. So that's going to be 1,800. That's the real estate on the number line between those two averages. And that's going to have to be divided into 6 parts because our proportion is in 6 parts. So we divide that into 6 parts. And so 1 part would be 1,800 divided by 6, which is 300. And so that means that 1 part is 1,800, 1 part is 300, 5 parts is 1,500, and so that tells us how that 1,800 is split up. So that means if we start at the mass of a car, which is the larger group, we only have to go 300. We have to go 1 part away from that up to the average. Or if we started at trucks, 3,000, we'd have to go 5 parts down from there, 1,500 down from there, to get to the average. Well, it's easier to go up from 1,200 just by 1 part. The distances from the car's mean to the total mean must be one of these parts, 300. So we just add 1,200 plus 300. That gives us the total mean of 1,500. Notice we could have gotten there also by starting at 3,000, going down 5 parts. 3,000 minus 1,500 also lands at 1,500. So that is a very different way to approach this problem. And notice also, this is the exact same answer we found the first time using a very different approach. So 2 very different ways, and as always, if you can solve a problem in 2 different ways, you really understand it well. Here's another practice problem. Pause the video and then we'll talk about this. Okay, at Didymus Corporation, there are just 2 classes of employees, silver and gold. The average salary of gold employees is $56,000 higher than that of silver employees. Guess it's good to be a gold employee here. If there are 120 gold employees and 120 silver employees and 160 gold employees, then the average salary for the company, the total average salary, is how much higher than the average salary for the silver employees. So the average salary for the lower employees. Okay. First thing we're going to do is figure out this ratio. 120 to 160, that's 12 over 16, which is 3 over 4. So the distance from the silver to the total is going to be 4 parts. It's going to be the longer distance, the slightly longer distance, because the silvers are a slightly smaller group. The distance from the total up to the average for the gold, that's only going to be 3 parts, because that's the larger group. It's going to have a smaller distance. Together, that's 7 parts, and that's going to have to equal $56,000. We'll divide, and we get 1 part is 8 or 8,000. And so now, if we're starting out from silver, we have to go up 4 parts. Well, 4 times 8 is 32, or $32,000. So the total is $32,000 higher than the average for the silver employees. One way to approach weighted averages is to find the sum. We can also find the proportion of each group and multiply each group average by that group's proportion and simply add those up. And if there are only 2 groups, the distances from the 2 group averages to the total average are in a ratio that is the reciprocal of the ratio of the proportions. And this final way of thinking about it, admittedly, it's very hard to put it into words in a way that's clear, and it can be very confusing when you first encounter it, but if you can learn to think about it this way, it will give you a powerful advantage on the test.